Right, so in this video I'm going to look at theorem number 9, and I'm going to look at proving theorem number 9, which states that in a parallelogram opposite sides are equal and opposite angles are equal. Again, I'm going to use these four headings here: given, to prove, construction, and proof. So we'll start with what we're given. So we're going to be given a parallelogram. So we're going to be given some kind of a parallelogram that will look something like this. And it's going to be called A, B, C, and D. So we're given a parallelogram. A, B, C, and D. So you would need to write this out. And when you're drawing these as well, use a ruler. I'm drawing it freehand at the moment, but you need to use a ruler. Right, so next thing we need to write down is what we need to prove. So what we need to prove in this case is that opposite sides and opposite angles are equal. So we need to write out two different things here. Opposite sides, first of all, that AB is going to be equal to CD. And we also need to show that BC is going to be equal to AD. Secondly, we need to show that the opposite angles are equal. So we need to show that the angle ABC is equal to the angle ADC. And also then we need to show that the angle BCD is going to be equal to the angle BAD. Okay, so this is what we need to prove. We need to prove that these two sides are equal, and these two sides are equal, and these two angles are equal, and these two angles here are equal. Okay, so let's move on to the next section then, which is our construction. So our construction is just simply going to involve drawing a diagonal on our parallelogram. So let's do that. So I'm just going to draw out this parallelogram again. So our parallelogram will look something like this. And it will have vertices A, B, C, and D. And we're going to construct a diagonal across here like this. Now remember that this side and this side are parallel, and this side here and this side here are parallel. So our construction just simply involves drawing a diagonal. The diagonal will be AC, from A to C. Okay, so now down to the actual proof itself. So proof. Right, so first of all, I'm just going to say that the angle BCA is good. This is this angle here. I'll just put a dot in here to show you which angle we're actually talking about. BCA is equal to the angle CAD. This angle here. Why? Because remember, this line here is parallel to this line here, and we have a line cutting through those two parallel lines. So this angle here is actually alternate to this angle here. So these are alternate angles. These are our reasons here. You must write in the reasons every time you write down a statement. You must write in a reason. So these are alternate angles. Now we also know that AC is just simply going to be equal to AC. The distance between A and C is going to be equal to the distance between A and C, because it's a common side of this triangle and this triangle this is a common side. So this is just a common side. And thirdly then we're just going to look at the angle BAC. BAC, so I'll just put 2 dots here to show you which angle I'm talking about. So the angle BAC is equal to this angle here, the angle ACD. Again, why? Because they're alternate. This side is parallel to this side and we have a line cutting through them. So this angle here is going to be alternate to this angle here. So again, we've got alternate angles. Okay. So next thing we're going to do then is just look at what we've got so far. We've got this angle equal to this angle here. So we've got this angle in this triangle equal to this angle in this triangle. This angle in this triangle equal to this angle in this triangle. And we have a side between the two angles that's common. So it's obviously equal to itself. So really what we've got here is this triangle being congruent to this triangle here. So in other words, the triangle ABC is congruent to the triangle ADC by angle, side, angle. Remember here, this is our angle here, if you like. This is our common side here, and this is our angle here, angle, side, angle. So we have congruency here. So this triangle is congruent to this triangle here. So that just simply means then that the side AB is equal to the side CD, because they're corresponding. They're corresponding sides. And also then the angle ABC is equal to the measure of the angle ADC, because they're corresponding angles. So similarly we can say then we can also say that the angle BAD is going to be equal to the angle BCD. We can use the same proof again by just drawing a diagonal across this way. We can prove this last line. So basically what we've done here is we've taken this triangle and we've proven that they're congruent, which means that they have the same size sides, corresponding sides, and they have the same size angles, interior angles. So that means that angle must be equal to this angle, which are two opposite angles, and then this side would be equal to this side, they're opposite sides. This side would be equal to this side here. And we can also just prove by just redrawing our diagonal and doing a similar kind of proof that this angle here, BCD, and BAD are equal. So that's it for theorem number 9.